Okay, so this is now going to be shear, and we're talking about example 2 continued. So this is going to be the third page. So we now want to work out the shear stress at the glue, having worked out the shear stress at the neutral axis. Probably it's a good idea to work out the stress at the neutral axis anyway, to make sure that the stress at the glue turns out to be smaller, because we would expect that the shear stress at the neutral axis to be higher. So let's draw out the section again, and then that line is going to be our neutral axis, and then all calculations start relative to the neutral axis, because that's our value for y. So in this bit here, we now want to work out the shear stress at the position of the glue. So if that's YC, then we know that we want to calculate our shear stress at a distance d2 minus YC. So our YC turned out to be 162.5 millimeters. So our d2 minus YC is going to turn out to be d2 minus y dot c is going to be equal to 37.5 millimeters. So I should have been able to do it in my head. So as before, we've got our section. So we'll draw our section. We'll draw our section out here again, and then 3, 4, 5. So we've got our section there with the neutral axis, as I've said, acting along there. So that's going to be our neutral axis, and we want to work out our shear stress at the distance of y of 37.5 millimeters. So we're going to be working out our shear stress acting below the glue, and we're also going to be working out our shear stress just acting above the glue. So we're going to be getting two values of shear stress, and let's just draw out our axis again. So that's y, and that's going to be our shear stress. So as before, we would expect the value there, and then it goes down like there, and then it goes out to the maximum value. So there's going to be one value. So one value is going to be calculated based on that. One value is going to be calculated based on that value, B2, and then the other value is going to be calculated based on the value B1. So now let's draw out the section where we want to calculate the value. So if that's going to be our neutral axis, then going up here, so again that's the neutral axis, so I've not drawn the rest of the section, and let's just shade that. So that distance there is going to be d2 minus yc, which is going to work out to be 37.5 millimeters. And we are going to be working out our tau y from our expression is going to be equal to v s dash y over I times b as a function of y. So in this case here, our b is either going to be b1 or b2, and our shear force is going to be the same as before. That's going to be 10 kilonewtons. Our distance y is going to turn out to be 37.5 millimeters, since we're working out the shear stress at the distance 37.5 millimeters, and we're going to be working out our s dash y relative to we're going to be working out our s dash y relative to the neutral axis. So let's deal with the s dash y, which is going to be at a distance of 37.5 millimeters. So our s dash y in this case, our s dash in this case here is going to end up b1 multiplied by d1 Yeah, what do you want? So b1 times d1, so b1 times d1 sorry, so we're talking about b2 multiplied by d2 minus yc, and that needs to be multiplied by the distance d2 minus yc divided by 2, because that distance there is going to be your d2 minus yc over 2. So we've got one portion, and then we've got the other portion which is below the neutral axis, and that portion there, that distance there is going to be yc. So we've got b2 multiplied by yc multiplied by yc over 2. So we've got our two bits which I've now shaded in two different colours. So you can see that along this line here, what y is going to be equal to 37.5 millimeters, which is going to be up here at the interface. So note that we shouldn't be adding these values together, because they're on different sides of the neutral axis. So we're going to have to subtract them, and we're going to have to take the modulus of them after our subtraction. So we'll end up with two positive values, and we can probably assume that this value is going to be the larger value. So let's just put a big bracket around there and stick a negative sign on, and then stick a plus sign on, and we will work out our value of S dash, which would turn out to be 6.25 times 10 to the 5 millimeters cubed. Now, of course, there's an easier way to arrive at that, and that's to look at the T above that's to look at the beam above it, where it doesn't cut the neutral axis. So let's write out that equation again, S dash at 37.5 millimeters, because we are still considering the section above we're still considering the section at a position of 37.5 millimeters, and that sum there, S dash, would be equal to B1 multiplied, of course, by D1, which is the depth, and that is then going to be multiplied by that being D1, so half that distance is going to be D1 over 2, and then that distance down to the neutral axis, that one is going to be equal to D2 minus YC. So we would then put D1 over 2, and then we would add that on to D2 minus YC. Okay, so, and if you did the calculation for that, you would also get 6.25 times 10 to the 5 millimeters cubed. So it is a good idea to, if you're worried, to check it by calculating both above and below, but using an appropriate strategy, you would probably realize that it's easier, one way is easier than the other, and in this case here it's easier to consider the area. In this case it's easier to consider the area above the line than it is below the line.